I am Ritam বিশ্বাস. We are making an automatic cloth carrying system. We are making this using Arduino. We design it in such a way that if it detects rain, then all clothes automatically enter in a room from where you can collect your clothes. We are adding other features that when the sun sets, then all the cloths enter in a room. One of our special features is that you can control it using your smartphone, using our app. We are using Arduino servo motors and rain sensor HC05 module and various kind of our electronic module for this project. It is designed such a way that if it detects rain and sunset, then it gives signal to servos and all clothes enter in a room. It is the total clothing solution. Thank you.
Hello everyone. Today I am going to talk about the block diagram represented in this screen, representing an automated cloth drying system integrated with weather-based controls. The system includes components: a solar panel, battery, Arduino motor, motor driver, controller, MOSFET, and motors. Let's dive into details. Solar panel. At the top left of the diagram, we have a solar panel. This solar panel harnesses energy from the sun and converts it into electrical energy. This energy is used to charge the battery, ensuring that the system remains operational when there is no direct sunlight. Battery. The battery generated by the solar panel is stored in the battery represented next to it. The battery acts as a backup as a power source, ensuring that the system can run continuously even during the cloudy weather or during the night. The battery is connected to both the Arduino and the motor driver controller to supply the necessary power for its operations. MOSFET. Next to the battery is the MOSFET. We have a MOSFET. The MOSFET acts as a switch control to the flow of current in the circuit, providing an efficient way to manage power between the battery and the motor driver controller. It allows the Arduino to control the motors directly, ensuring precise control over the motors when activated. Arduino. The heart of our control system is the Arduino shown next. It acts as the brain, receiving inputs from various sensors including rain sensor and controlling the motors accordingly. The Arduino processes weather data and decides when to activate the motors, automatically moving the drying racks based on environmental conditions. Motor driver controller. The Arduino sends signals to the motor driver controller, which is responsible for driving the motors based on the commands received. It serves as an intermediary between the low power signals from the Arduino and the high power motors, allowing precise control of motor operations. Rain sensors. One of the critical sensors connected to the Arduino is the rain sensor, which is placed outside to detect rain. When the rain sensor detects moisture or raindrops, it sends a signal to the Arduino indicating that it has started raining. This input triggers the Arduino to send a command to the motor driver controller to activate the motors, retracting the drying racks to prevent the clothes from getting wet. Moving down to the central part of the diagram, we have a rectangular area labeled called roof. Around the perimeter of the roof are small icons representing the motors. These motors are placed at strategic points along the edges of the roof to operate movement of the drying racks. The dotted lines connecting the motors show how each motor is linked to the controller and to each other. When the Arduino receives a signal from the rain sensor, it activates these motors to automatically retract the drying racks. So now let's deep dive in how does this motor work. When the solar panel receives sunlight, it generates energy and stores it into the battery. The Arduino continuously motors weather conditions using the connected rain sensor and other sensors. If the rain is detected by the Arduino, it sends a command to the motor drive controller. The motor drive controller then activates the motors around the roof, automatically retracing the drying racks to prevent clothes from getting wet. Once the conditions are suitable for drying again, the Arduino commands the motors to extend the racks back out. This automated drying machine provides a hands-free solution for managing laundry drying responsibly, responding intelligently to rain and weather changes. With the use of renewable energy, it's both efficient and eco-friendly, ensuring convenience while reducing reliance on external power sources.
Now here it is code for automatic cloth care system. So in this code, first we have to select all those pin. Here it is pin for servo, and it is pin for rain sensor, it is pin for light sensor, it is pin for fan relay, it is pin for heat relay. In this voice setup system, I discuss about all those pin signal like here it is pin for light, and it is pin for rain, it is pin for fan relay, it is pin for heat relay. In this voice loop section, first I consider all the input values coming from the input like A0 and A1. Then I wrote all the logics, and here it is mentioned. Now it is wrote like that: when light is detected, the spring system will active and take out cloth from shade. And when light is not detected, most probably in evening, the spring system take the cloth inside the shade. This logic also used for rain detection system. When light and rain both of them are detected, then the system will active and take the cloth inside the shade.
So previously we had given an overview what is a automatic cloth care. After that we had given you the details of the code and the parts that we have used in this prototype. So this is a prototype that we have discussed earlier. In this prototype we have taken a LED light as a sun, a control box is there where Arduino kits is present, a shade is there where all the cloths will be inserted in, and a heater is there along with a rain sensor that will sense the rain and will take the cloths inside the shade.
Now we will discuss about the working function of our prototype. So it is a sun and it is a light sensor. When the light sensor detect light, the spring system will pull out the cloth outside, and when the light is not detected in this sensor, the cloth automatically inside the shade.
So this is the rain sensor. When rain is occurs, then the shades. This is the light sensor that detects the light. So the cloth is outside. This is the rain sensor that detects the rain. When a single drop of rain is fall, then the cloth is inside the shade. This is our heater that heats the cloths and warm the cloths very as it is possible.
The advantage of our prototype is there is a heater set inside the shade that will warm the clothes 40% faster than the normal radiation of the sun or the light that is coming out from the sun. Point number one. Point number two is the people who are staying in urban areas or who are busy in their job life, they can't sense or they can manually protect the clothes from wetting in rain, or they can sense the light so that they can pull out the clothing. So we have created in such a way that it will automatically sense the light or the rain, and it will do the needful for the customer. As an engineer, it is our job to design a prototype in such a way that it will make the life of the most of the people easier.